The following question reads that which of these polymers is a protein? So the first thing I'm going to do is protein. I'm going to describe what a protein looks like. A polymer protein is made from monomers, which are called amino acid. A typical amino acid has this functional group. It's going to have a group of atoms, which I'm going to represent by a square box. What this box means is that it could contain anything. It could contain any carbon, hydrogen, oxygen, sulfur, nitrogen atoms grouped together in whatever arrangement. But an amino acid has this property that it has an amine group on one side, which means that an NH2 group is on one side and there is a carboxylic group on the other side. So this is one monomer and this is your amino acid. So monomer is the single unit from which a polymer is made. So you're going to have multiple such groups. So here's another amino acid. Remember, don't get confused with the box. The box could be any group of atoms or structures or whatever. We're not concerned with that. So I've drawn a box instead. So there's another amino acid. So I'm going to at least draw, let's draw 3 amino acids. And I'm going to link them together. It's called condensation polymerization, by which proteins are formed. So each amino acid has a carboxylic acid functional group and an amine functional group. And what happens is that these monomers, they undergo condensation polymerization, where the amine loses its hydrogen, whereas the carboxylic acid loses its OH group, and the two groups get together to form water. So the same thing happens on this side as well, and the amine loses its H, the carboxylic acid loses its OH. So water is formed, and this keeps on continuing. So on this side, let's put dots over here to show that a very long chain is being formed. What eventually happens then is that we're going to get rid of these groups. So let's rub them off. This over here is gone. So I'm going to remove all of this. All these atoms are gone. They're gone in the form of water. They've formed water. These groups are also gone. H2O is formed instead. This is gone. And an H2O molecule is formed. This side is also gone. And an H2O molecule is formed. And you're left with this. And what now each of the atoms, for example, nitrogen is not complete. It has lost one of its atoms. So it is short of one bond. This carbon is also short of one bond. This nitrogen is short of one bond. So they all start bonding with each other. This nitrogen would bond with this carbon atom. This nitrogen over here would bond with this carbon atom. This nitrogen would continue this onwards. This carbon would continue bonding with some other amino acid on this side as well. So now if you look carefully, nitrogen is now making 3 bonds. Carbon is making 4 bonds. So the bonding is complete. So this is the structure of an amino acid. Now what you need to know is he's given you 4 options: A, B, C and D. Remember, an amino acid has the same groups that are repeating over and over again. So it's going to form a very long chain where the same group is repeating. It's repeatedly continuing over and over again. So the short form of writing an amino acid is that what you're going to do is you're going to pick this group. This is your smallest repeat unit, and you would write an N over here. This would indicate that the same thing repeats again and then again. So it keeps on repeating over and over again, and it ends up forming a very, very long chain of a polymer, which is called a protein. So these brackets and N represent that. Now one thing we need to now answer this question, which is that he's given us 4 options and we need to figure out which one is an amino acid. So there's a quick hint over here that a protein always has a nitrogen atom in its linkages, and there's only one compound that has nitrogen in it, which is option D. So it has to be option D because every protein is going to contain this nitrogen atom in it. Proteins are made from amides. They are a form of polyamides. So they are going to contain nitrogen. So this is going to be your correct option because none of the other options have nitrogen in them.